When you think about how construction has changed over time, you think about how USACE existed well before computers ever did. And so you think about blueprints and plans and how all of that was done by hand, measurement, meticulously, and then reproduced by hand through almost like a game of telephone in the creation of a building. As computers came around, it turned into automated softwares that you're able to now draw them and send those files to other people for them to replicate. But coming even further forward now, where we can use the designs that you've built in that computer to be able to reproduce the same exact design in the real environment, which has always been a challenge for construction. Because typically, when you have something built, you send the files to a contractor to build, and that contractor interprets those plans the best they can to make that structure. Well, with additive construction, what you're able to do now is directly put those plans into the computer and it'll spit out exactly what you put in. And so we're able to reduce a lot of the errors associated with construction and overall improve the build quality of those structures. So when we think about modernizing construction, we're really looking to augment the worker. So reduce the amount of hard labor those workers go through and change construction from the fundamentals. So you think about how the nail gun improved construction away from the hammer and nail. You're still doing the same task, you're just able to do it more efficiently and with a lot less labor and work associated with it. Additive construction can perform similarly for concrete. Now, instead of building formwork and doing a lot of manual labor to be able to pour massive amounts of concrete, we're able to strategically place concrete or other materials where we want them to be. And so in that process, you're able to reduce the amount of hard labor, you're able to reduce the amount of materials because you're not placing as much concrete or building extra formwork that's just thrown away. And then you're also able to reduce the amount of time to implementation because you're using this machine to basically efficiently complete a task similarly to how the nail gun changed construction in general. So if you picture an expeditionary area or even in a disaster relief situation, people may need barriers to either direct traffic or to stop water from coming in. And this type of technology provides the capability for you to produce whatever your site needs, from everything from buildings to gap crossings, all the way down to small construction barriers, with just a change of a file. And so what that provides you is that ability to have a lot of independence when you're in the field and produce what you need. And so we can look at structures and say, how can we apply modern technologies such as 3D printing to basically take a technology and reduce the amount of manpower, cost, time, in order to produce a structure that potentially could be better than what exists today. What that could mean is we're looking at complex geometries, so how can we make buildings stronger? How can we make buildings have different types of benefits? Developing additive construction technology and working underneath USACE has allowed for this technology to not only develop rapidly, but to develop with the massive amounts of knowledge and history that experts within the Corps of Engineers have. So when we're talking about how can we implement this technology in innovative ways in construction, the Corps of Engineers is there to bring that body of knowledge through to say, this structure has these potentials and these capabilities to use these new technologies and look at how that can improve construction in general. So that role that the U.S. Army Corps of Engineers really plays is that ability to be that third party looking out for the best interest of the public